All right, everyone, very quickly, let's talk about a numpy library for generating random numbers. Numpy is a giant library, one of the most fundamental libraries in Python that applied packages such as a lot more applied packages that we know, such as pandas, relies fully on numpy. Even matplotlib relies on numpy. So we are going to import it using import numpy, which stands for numerical Python, as NP. The whole world uses that. Don't change that. All right. Then the right way of generating random numbers here is I'm going to say RNDs, random numbers, is equal to np dot random dot default RNG, random number generation. What this does, it generates a random number generator, right? So again, you got to learn this. This is, I mean, there is no magic into all of a sudden knowing this. You have to experience it and learn it. And then we are going to say RNDs dot tab. All right. Now you have a lot more option than other libraries. For example, you can generate random number from gamma, from hypergeometric, from logistic, log normal, multinomial, normal. Let's normal. Normal. I don't know how this is going to work. So I'm going to say normal question mark, and it is going to say normal. You have to provide location. You have to provide a scale. Location is mu, average, and scale is sigma. And you can read about it right here. All right. It says scale is standard deviation, right? And then something that is super exciting is size equal to none, meaning size by default it's none. It's going to generate one random number. Size, if you look at the size, it says int or a tuple of ints. All right. So you can generate one number, you can generate a vector of random numbers, you can generate a matrix of random numbers, and so on and so forth. So let's try that. All right. And if you scroll down, you're going to see a bunch of examples. All right. So I'm going to say um, norm RNDs is equal to np dot I'm sorry, RNDs. We have created this RNDS, right? RNDS, remember, we created this. RNDS, we have created this. RNDS was that default RNG. By the way, if you don't use default RNG, you're gonna lose discussion points, all right? RNDs data normal. So I'm going to say location. You can do that. Location is equal to 10, all right? Scale is equal to 3, and size is equal to 1. Let's see what we get. All right. So norm RND. So you're gonna get you see, it gives you array, it gives you a vector. All right, by default, because numpy works with vectors, it's going to give you a vector even though it's a vector of size 1. Right. If I say give me size 6, it's going to give you a vector of size 6. All right. This is and I want to get size 2000. I don't need to see a vector of 2000. I'm going to say plt.hist, histogram of what? plt.histogram of norm RNDs, and again color equal to, this time we are going to go with red, and we can go with beans equal to, so let me run this, and then we are going to see what we get. Okay, there we go. You have that, right? So of course you are drawing from normal random number with mean of 10, majority is going to be around 10. All right. And you can say, if you don't like how it looks like, let's see, 1 2 3 4 5 6 7 8 9 10. It looks like it has used the 10 bins or 10 containers. All right. We can say bins. I believe bins is equal to, you can say 30, right? Make it more granular, and you are going to get a more granular distribution right here. Again, normal is just one of the many that you can choose for your discussion.